Well, on this week's video, we received authorization to make the changes to this conversion that was started by someone else. And so we've made a quick little list of things to be done. It's not in order, but rear sail containment, front sail hold down, change the most positive location, check the charge port wiring, new mounting location of the vacuum pump, and coolant reservoir, vacuum reservoir, change the component board mounting, look into the coolant leak, clean up the transmission fluid that's on that cross member and thus dripping on the floor, protect the cables, test the 12-volt circuits, clean up the wiring, test all systems, and program the JLD 404 and controller. That's just a broad partial list, and like I said, that's, you know, I've got them numbered, but that's not in any particular hierarchy. So what we have here, what is kind of the top of the list, is this rear battery containment, or lack thereof. The batteries are just in there loose, pretty much. So they got some foam spacing, but they sit between the tailgate and the back seat, and so that really doesn't offer proper, you know, containment. They're kept from coming up by this board right here, or plate, piece of metal with some rubber over it. It's quite heavy looking, and so these need to be put in a box, properly contained and supported. So that's the first priority. We're going to remove this plate and get access to these cells, and then we'll take our measurements and everything, make our design. I think we're going to change things a little bit, see if we can do that. Since this is inside the vehicle, you don't want these coming loose and going anywhere. And so the other thing that we're going to do, as I mentioned, the most positive location. Well, right now, this is the most positive point in the battery pack, and it goes from here all the way up to here, to our main disconnect. Well, I like to be able to have, you know, the power come out of your pack, say in a location like this, it comes out and goes directly to my switch. So when I shut this off, there's, you know, there's only power from here to here then, you know. So we're going to redo that, and we're going to figure out a way to do everything so we don't have to, you know, change any cables or anything like that. We're going to figure out how we can, you know, arrange the interconnects and everything to put the most positive and most negative and the other connections where we want them. And so this then, which is now coming, you know, comes out of this pack or into this pack, however you want to look at it. Well, we'll say going out. This is the most positive end. And so this is the negative side of this rear pack, which goes up through the fuse into the front pack. And then the front pack most negative point is right here, the shunt, or should be. We're going to check all that. Then another thing on the list was to protect the cabling. Well, you can see, you know, it's already getting chewed up on the sheet metal. We're going to, you know, sleeve things. Here's another example. We're just going to change things, follow all of the routing, and make sure everything's not, you know, we're not redoing this, but we're just going to pick out the the issues that are going to cause, a problem down the road, and rectify those. And this is one of them. This is not going to stay here very long. And so a bigger one than that was, like I said, we're going to redo these little screws, these 8 or 10, number 10 screws. I don't know. I think they're number 10. Might be a number 8. Anyway, we're going to take those out, re-tap the holes, drill them out, tap them for 1/4 inch, put some washers, lock washers on here, so that it's a little more permanent setup. And so that kind of thing to the board. We're also going to, I think, trim the board in some places. Like, you can hear it hitting up against the booster up there. This whole mounting system on the all thread just, doesn't fly with me. So we're going to redo all that. We're going to change this component board mounting system. I want to make it so that the board can be removed easily or tilted up, preferably kind of hinged, so you have access to the cells below. Right now, we can't check, see if those interconnects are tight. We can't check to see what the individual cell voltages are, which doesn't matter. I mean, the tightness does, but using these Nordlock washers, experience shows us that's not an issue. But, walking into the middle like this, I don't know if these have been properly bottom balanced or what the deal is, or balanced at all. I don't know. But kind of hard to get in there and find that out. So I like to have things that have a level of serviceability, and that's what we're going to try to do with this. And so we're going to relocate the reservoir here and the vacuum pump, vacuum reservoir, to where they're not attached to this plate, so that we can possibly hinge this plate. We'll change the wiring, the way it's run and so forth, so that it allows for that type of thing. We're also going to have to relocate the coolant reservoir, because it's mounted here also. And like I said, the clearance is here. I don't know if you can see. I mean, there's it's hitting. So we've got the coolant leak. So we've got coolant leaking on the board here. So my guess is that the coolant is coming from the chill plate. In other words, it's leaking. The mating of the chill plate to the controller, that mating surface, there's a leak there. Somebody used some cleaner or something on this. I just noticed the information on the sticker here for the controller has all been removed, and this is a do not remove sticker, voids the warranty. It looks like it's about ready to come off. It's all removed. So they used some kind of cleaner on there. I wonder, you just don't know what's going on before you get into the picture here. I really don't like getting in the middle of these things. You just kind of do it as a favor for people. And again, we've got the motor cables running over the edge, and this edge of this aluminum is kind of sharp, and so you don't want your stuff running over the edge like that, because it's going to wear through eventually through the cable insulation, and you're going to have a big problem. So lots of things, lots of little things to look at. We're going to go through and make sure that the traction pack system is all wired correctly, and we'll do that when we're putting things back together. Like I mentioned in the last video, we're going to have to take all these components off and to remove this board, because we don't want all this weight on there when we're trying to remove this board, and you know, around nice fresh paint and around all those battery terminals. We'll put something down there between it. We'll slide something between there for extra protection. But yeah, but these have to go. This is just a poor mounting setup. You can see the little movement here. I'm not applying that much pressure. Going down the road, or if you have to make an emergency stop, or if you hit something, that's just, I just don't like that design. So we're going to make some modifications, do some testing, and get this thing a little more ship shape. And like I said, we're going to start right back here, and if I don't get any more interruptions, we're going to start right now. Well, I was down underneath here looking to see the location of the bolts that hold down that plate up above, and so located those, and I'm kind of just looking around, and you can see where the battery cables are going through the floor of the rear of the Jeep here, and I'm not too excited to see that. Anyway, nice sharp edges of metal right there. I mean, that's just a time bomb, folks. Please don't do that. So what we're going to do is dang it, we're gonna put some gland nuts in there, but that means we're gonna have to cut those lugs off and put new lugs on, trying to keep the work and expense and everything to, you know, much a minimum as possible. So anyway, but that needs to be done. You can't leave a situation like that. So we got to protect that. I mean, we could go with the grommet, but I think I'll feel better with some gland nuts. But we'll see. We'll see what's going on here. May relocate that altogether. I don't know. We'll see. We're not far enough along yet to make any decisions. So let's get rolling. So here's the rear pack with that cover removed. And I think the cables will be long enough that we'll be able to make things work. You can see where it comes through the floor down there. Okay, so what's next? Well, what's next is we're going to remove one of these interconnects. And by removing one of these interconnects, we de-energize this back pack. And you know, we don't have to worry about a circuit. Wow, looks like it was wearing here. Let's go look at the bottom side of that board. Okay, here it is. Yep, it's almost worn all the way through this rubber, and that's an aluminum plate right there. So that's 1/4 inch. Anyway, we're gonna go through and these need to come out. Here we've got a piece of foam. So, like I said, we've already got some holes here, so we'll probably reuse those as part of our hold down, setup, and then go through the bottom below also. But we're going to reconfigure this, and anyway, we'll continue on. Like I said, I'm going to remove one of these interconnects first, and then next I'll disconnect the cables, and then I'll do the rest of the interconnects so we can pull these cells out. But you know what, before I do that, just out of curiosity, let's throw a volt gauge on it and see what's going on. Okay, got the voltmeter in the picture. Hopefully we've got some of the cells in here. We're going to take a look and see what we have, and we'll start right here and see if I can do it without blocking the camera. 2.82, 2.87, 2.75, 2.77. Whoa. 2.60, 2.57, 2.84, 2.91, 2.70, 2.82. I don't need to go any further to know the big picture. And that is, we're going to have to go through and bottom balance these cells. They're all over the place. So yeah, so that's just another aspect that we need to take care of. We'll get on that right away too. And yeah, not what I wanted to see in all this. This is just more work, and it'd be more expense for the owners, but unfortunately it needs to be done. So back to removing the cells. So I'm removing the interconnects in preparation for removing the cells from the back of the Jeep. And I removed this one, and it was in like this, and I could see, you know, look a little smoked there. But you can see somebody made a mistake. So that would wake you up. Would get hot real quick. So here's the area with the cells removed. What we have, the seat slopes back, so you have to go at the top end of the cells and back to the tailgate. And what we have depth wise is 13.5 inches. It's more at the bottom, but that doesn't matter at this point. We want to know the minimum dimensions. And then width from inside the fender well to the other one is 35 3/4. So that's what we have to work with, and that's where we're going to start. And we're going to figure out how we configure these cells to fit that area best. So that's what I'm on to now. So we removed the rear cells and have taken measurements and have placed an order with the fab shop to have a battery box made for the rear of this Jeep. So these cells will be properly contained. And so once they're removed, we also measured the voltage. And kind of surprised by what I see. I don't know who did what to these, but boy, oh boy, they're all over the place. So you can see we've got two cells that are below this chemistry's minimum cell voltage. We've got a 0.91 volt cell, and we got one that's at 2.12 volts. Both of those cells are now toast. We will not use those. We have one that's close. The minimum cell voltage for lithium iron phosphate is 2.5 volts. We've got one at 2.57. And then we've got, you can see the rest of them. We have one that is at the target voltage that we want for bottom balancing. That's cell number on my list, number 9, 2.75 volts. And so I've got the two that are toast and red, and then in orange, if it shows up well on camera, I've got the ones that are below our target voltage, and then the green target, and then in purple, I've got the cells that are above that. So it looks like our highest voltage cell is 3.25 volts. So what a, variance here from 3.25 volts to 0.91. I just don't understand. I just don't know what, when you come in, in the middle of the game, you just don't know. So we saw our cells that sat in the desert in the Volkswagen Transporter Doka for 8 years. And those, we're driving the vehicle still. They were all fine. But we bottom balanced those back in 2013. And then the car was driven, and then it sat for over 7 years. So it's typically not the cells. So there was something that either caused these things to get, bled off or something. I don't know. I don't know. And I'm not looking to see what that is, because we're going to redo this correctly. So what the culprit was really isn't something we're going to invest time in at this point. But the front cells are next. We got to remove components from that component board and get that component board off, because we have coolant that's leaking, and so we're going to find the source of that real quick, and then we want to get those cells out because of the coolant leaking on top of the cells can cause a path, an electrical path that will cause these things to start to discharge, and we don't want that. So that's the latest status of what this Jeep repair project looks like, and another interesting thing is looks to me like there's 27 cells in the front. What I can see, peering underneath that component plate, looks like 3 rows of 9 cells each, so that'd be 27, and there was 22 in the rear. So that gives us 49 by my math. Well, the maximum we normally use for a Curtis 1239, which has a maximum input voltage of 170 volts, and we charge to 3.5 volts each, so I'll let you do the math, but normally we use a maximum of 48 cells. So hopefully we don't have any more bad cells, but this would put us down 1 cell, which is going to make things fit in the rear better. So we planned the box for 20 cells in the back instead of 22. So all of that will be fine. We'll reprofile the, choose a different algorithm for the charger, and everything will be fine as long as all the front cells are okay. If they're not, well, I don't I don't like the options at that point, but we'll see what happens when we get there.